Okay, we're looking at the kind of third example problem, and this essentially is, and I'm going to go ahead and clear my tools. This essentially is a problem that's not that uncommon, to tell you the truth. You've got basically something that's kind of got a tower here in some way, shape, or form. It has some forces applied to it, and then you have two reactive forces. One, of course, is the wire, the cable pulling it down to the ground that way, and the other one then is this kind of reactive force. Now, we checked it before, and we're going to look at mathematically on the right. What's behind this is not important. We'll try to fly around this one in SketchUp, but if you think about it at this point, the value, we really have these in order, but these two are important, and we're going to go right now and evaluate, if you would, what is the stress is just below this one here, which is 2.5 up the member. So that, if you remember, that one is behind us. The only thing that's in front of us now is, in fact, RF, right? Is this one here. So the only force that's going to be in front of us is this combination, which of course is these two here. Now, what is our radial vector? Well, our radial vector is, in fact, if we're right here, it's 0, minus 2.5 for both of these cases. So if I go into here, for there, my radial vector is from, I'm shifting my 0, 0 to just below that R reaction at F and B, and so my radial vector is minus 2.5, and my radial vector here is minus 2.5. So now as we do this, I'm going to go backwards here, File, Exit, and Return. Now these are the only two. So these are the only two that are in front of us. This one here, and this one is there. Right? That one is behind us as we climb up the pole. That one's behind us as we climb up the pole. And even that one is behind us because we're right below here. So the free body, of course, looks something like this. We've got a free body. It's subject to an axial force, some sort of shear force, and then a bending force. Now, what we know is what's behind us is not important, and so the only force I have is right out there. We want to know what the internal bending is. Well, if you look at this, we definitely know that, in fact, it has a value of minus 8.49 in the x component. In other words, it's 8.49 this way, and it has a value of minus 12.1. It has a shear force which is negative in that way. If you think about that being positive, that's being negative 12.1. And the moment then is the addition of these two moments. If you think about that, this is going to have some bending. It's going to have a certain particular shape. As it would, you'll see this is going to have to come in. It will deflect in a certain way from here and then be pulled back. So what you've got is something that's bending out this way, and so it's actually compression in the bottom fibers. So you may have to worry about which way this thing bends. But what is the determinant of these two? Well, now you got to take out that calculator, and as much as I don't like to do it, let me take out a calculator and talk about the fact that in all reality, you could have put it all here in the calculator anyway. And so that general calculation, I'm going to turn it on. You see that's all. We could have put all these things within, but we have basically a positive moment. If you think about this being pulled this way based on what our definitions are, there's going to be a positive moment and a positive moment. Therefore, they're both turning in a certain way. These two, it's going to be a positive moment and no moment, and we're going to have a negative moment inside the beam, which would tell us it's shaped the way we think it is. So what do we have? Well, we have a positive moment here. This is going to be 2.5 times 8.49. And here we have a 0 moment, so our moment is going to be a minus 21.22 In other words, kip feet or whatever this is, minus 21.22. So my moment here, right at here, at that point right there is minus 22 or thereabouts. My force would be 8.49 and 12.1. If I want to move up through the structure, I can go ahead and start including some more of these now. If I want to all the way, let's say I want to go up the structure to right there, just on the right side of that. Now, the ones that will be part of the equation will be, in fact, this one, of course, these two, and finally the sense that this is what, 0 and 5. Depending on where I am, if I'm past that, if I'm over here, if you would, then this also would be included. Or you could turn around and evaluate based on these two. So what's behind you is a definition. I generally think it's nice to work from the left to the right because this general sense of positive, we generally do a fair bit like that. But in this case, to get the sum, if you want to get the internal reactions right there, just to the right of the 11F, right, you would include 1, 2, these 3, 4, you'd add the forces. In other words, you'd add the 1.31, 8.49, and a couple of these. And then your internal force would be the opposite. You'd add the y's. Your internal force would be the opposite. And then your moment would be the opposite of these vectors. You have to think about it and draw it. That's how you do what's behind this is not important in a basic frame here that's supported by a pin joint and a reactive cable. And a reactive cable, of course, gives you unknown force of known magnitude. The process here, as always, I'm going to finally go ahead and review how to add 3 vectors together, the applied vectors, since I've got a little bit of time here. I'm going to do that first and foremost by whatever that layer is here. That layer here, I'm going to click on it. That layer is force reactive. I'm going to go to the layers here. Freeze that out. Both of my force reactives, how can I add those vectors? Let's think if we can do it. Let's try it. Can we? A little risky, but why not? You've got this force and that force. So I'm going to turn on my shift right click, my object snap settings. It's amazing what you teach and then you forget, or what you learn and then remember. But I know I grabbed this from a student. I'm going to grab here. Take it around here a little bit. I've got to make sure my object snap is on. As I go here, go along that direction, I go to here, it finds it. So I don't want to do that. I'm going to do back to here. I'm going to go left click space bar, kind of get that intersection, get that going, get this going, get that intersection. When it kicks it, I get that to there. That force is going that way. This force, left click, move to the end point there. These are both going from there. We decided we would kick. We're going to click this one. These go from here, so I'm going to go left click spacebar, move to the end point. We decided maybe, or we didn't, that we're going to go ahead and keep that first one. Left click to the end point here. Undo, redo. Got that one there. I've got to kind of see if I can get this done, running out of time, but I'm going to left click spacebar, move to the end point. I grab, pull, take it all over the place, and then take it to the end point there. You've got basically at this point 2 forces that are pretty darn parallel. Middle ground of that, but I guess I can try to do this. Boy, they're really odd. Boy, you can really start to think about visually thinking these 2 are going right down the middle. You can list them. 291, 292. Boy, they're going to intersect way the heck out there. You'll never be able to do that any other way except for in a pinch, breaking the rules, I know. Don't want to do that. Line from near here, perpendicular to, right? Move this one from the endpoint there to the midpoint. And I'm going to grab that one. Remember, of course, left click, spacebar, move to the endpoint. Remember, those were the sum of the reactive forces here, if those are all together. So that torque, force times distance, has to equal that force times distance. You can kind of start to see it there. If this is going this way and this way, of course, we've already recalculated them. We've put them there. And so let me just see if in fact it is. Line from the end of here. Got to stop. Thanks for listening. Bye.